Hey guys, happy St. Patrick's Day, first of all. Hope you are handling your day 2 of isolation. I'm going a little stir crazy already, but that's okay. So I tried looking online to find a good video to show you these graphing rational functions, and I decided that I do it better. So I'm going to do a video showing you some examples and then giving you some homework for today. So we're going to get right to it. Thank you to Meredith, who's home from college. Not wanting to be home from college, but is. So let's go. All right, so we're going to be graphing rational functions, which is section 2.7 in your book. I sent you this sheet already, so hopefully you have it or printed it or whatever. It's a nice little step-by-step on how to get this stuff done. So if you look on there, they're talking about they have this rational function here. I know it's ugly, but that's a rational function. It's just with different variables. A sub n and b sub m are leading coefficients. Okay, so it's nothing crazy. It just looks different. End behavior, we're going to call it the asymptote instead of the horizontal asymptote for a couple of different reasons. Today we're going to look at the first and second case where they are horizontal asymptotes. Okay. So this n is the degree of the numerator, so that would be a 2. And the m is the degree of the denominator, which this would be a 1. So they're talking about degrees here, what's happening. All right. So the first equation I'm going to use is pretty simple. I'm going to do this on some graph paper here. Equals 2 over x plus 3. All right, and we've already done that with our transformations, and we already know how to do this. We go to the left 3. That's our vertical asymptote, right? And there's no shift up or down, so we have a horizontal asymptote here. We go over 1, up 2 because of our vertical. We're just going to do a quick little sketch. Okay, well, I'm going to show you how to do that graph and others without the transformations that we've known. So this end behavior that they're calling it now, the horizontal, was y equals 0, right? The same thing would hold true if like the equation was 4 over x minus 7. There's no vertical shift up or down, so it's still y equals 0. So the first way that if your degree of your numerator is less than the degree of your denominator, then you have y equals 0 as your end behavior. Okay, and that holds true every single time. Pretty simple, basic. The next case scenario, and we'll go back to graphing those. Those are, well, you already know how to do them, but the next case scenarios we're going to do when they're equal to one another. And I have an example of x minus 2 over x minus 4, okay? I did this out before. This, if we had looked at it prior to, with transformations, is this equation, all right? If you get a common denominator here and simplify, you get this back, okay? So this one here, like I said, we know we'd go to the right 4 for our vertical, and then we would shift it up 1 for that, okay? Again, these two are the same equations, so how is it we can come up with that based on this equation, okay? So there's a couple steps to follow, make your life a little easier. It says to confirm your end behavior. So my end behavior here, because the degrees are equal to each other, it's a 1 and a 1. All right, it tells you that it's going to be equal to y equals the leading coefficient of your numerator over the leading coefficient of your denominator. That's a 1, and that's a 1. So it's 1 over 1. So we're at y equals 1, which lo and behold, we already have that. Okay, so that's our end behavior. Our numerator and denominator are already factored. The holes we're not getting into today. So the next thing is to figure out our vertical asymptotes. Okay, vertical asymptote is where the denominator can't be equal to 0. So we're just going to take the denominator instead of equal to 0, and I get an equation of y equals 4. Okay, make sure it's in x equals 4, and make sure it's in equation format. And look at that, we already have that up there, so that worked. The next couple of things that will help us, again, sketch these graphs is we want to figure out what is the x-intercepts. Again, x-intercept 0, solutions, all of those things. If we take the numerator and we set that equal to 0, we get x equals 2. So that will give us the 0.2 comma 0 on our graph. So I go here, 2, 0. That makes logical sense. All right, the other thing we can find is our y-intercept. Our y-intercept is we let x equal 0, and we get -2 over -4, which is a half. So that's our y-intercept, 0 and a half. And that, again, makes sense with our graph, what we have for our asymptotes and everything. So the nice thing about this is that you only have to plot the points that are listed here. Okay, you don't have to go above and beyond. This, I know, goes like that. Okay, I can't cross my x-axis any other time except where my x-intercept is at. These are my guidelines, so I'm going to approach those, right? So we know if it's a function, I can't be here, right? Because I can't be on top of one another. And we already know what the rational function looks like, so we know that we should be up here. I just sketched it. You do not have to plot any points, okay? This is a little bit different, a little simpler, okay? If you're not sure of yourself, you can always go back in and check a point. 1, 2, 3, 4, 5, 6. So if we plug in 6, you get 4 over 2, which is 2, which is almost what I got there. So I'm in the right spot, okay? So that's the extent of graphing the rational function. So if you take a look at the other problem that we looked at first, we get 2 over x plus 3. All right, our end behavior was y equals 0, so I got that guy in there. My vertical asymptote was x plus 3 equals 0, so x equals -3. I got that guy in there, right? There is no x-intercept, none. My y-intercept is 2 over 3, so 2/3, which is, I don't know, right about here. Okay, so that's the only point that I have to be able to plot on my graph. All right, because there's no other points. So with my end behavior, I can't cross it because it's on the x-intercept and there's no x-intercept. So I have to follow those asymptotes and I can't cross anything. And I can only cross my y-axis at a y-intercept. Okay, so that means I can't be down here because I'd be crossing my y-axis. And because I know what my rational function looks like, I'm down here. Okay. So again, check a point, see if it works. If you should be down here, up there, you can always go back and do that. All right, so hopefully this was helpful. I will post, I'm only giving you a couple homework problems to do. Try them on your own and then use your graphing calculator or Desmos to check your answer. And then send me a picture of your graphs. And that will be your homework for tomorrow. All right. Have a great day, guys. Bye.